SEIG after the conversion, means the input of the buck converter is set. Okay, voltage and current. So these figures show the all the sensing units. Okay, sensing units. So these are the voltage sensors, and the corresponding the filters are also. This is the current sensor here used here, and the buck converter switches are shown here, and this is the rectifier which is marked in this figure. Okay, so this individual unit is prepared, individually tested, then we'll go for the controller implementation. Okay, so first you need to test it in open loop, whether each converter is operating or not. Then we will go for a closed loop operation. Okay, so this is the entire wind and battery based system. Wind means this is a DC motor. Basically, from confusion is a wind emulator with a SEIG set. And we have also after this can have another voltage level, and this bus voltage like a 220 volt. We have instead of SEIG we have gone for a PMSC, combined magnet synchronous interface system. Okay. So obviously based on your different machine, your control pattern output, this MPPT control technique is remaining same. But depending on your output voltage and your bus voltage, you have to choose the corresponding converter, and accordingly you have to do the redesign. Suppose this is a 1 HP motor set, but after that I went for a 2 kilowatt or 1.5 kilowatt machine. So obviously all my design values will change again. So what I want to say is, when you are choosing your system, you choose it properly, or whatever. Suppose you have the machine with you, take that one and accordingly you have to do your design. You cannot directly use my system what I have used. In simulation everything is possible, but when we are going for implementation, so again depending on the availability you have to do it. So this is the single wind-based system with a 48 volt system I have mentioned here. Okay. Now it comes with a power management system. Okay, we have tried to extract maximum power from wind. With variation of wind speed also we have seen, okay, it is tracking the maximum power. Those results I have not seen. But shown here, I will come to the result after explaining this power management. What we did in this power management, all the voltage of each system voltage and currents are set. Okay, we have calculated the power corresponding. We are also monitoring the SOC. We have tried to first operate the battery. We are assuming that and also kept the battery in the standard means normal condition. Okay, that is SOC is between 50 to, first we have taken that thing means within 50% to that SOC percentage is 50% to 90%. Okay, so that is that is I am saying as a normal operating scenario. Normal operating scenario. Okay, so that means my battery is in a safe condition and I can do my operation of generating the power from wind, and if the load power is less, I can store it in the battery. Those operations, basic operations we have tested. So here the wind system is operated in MPPT mode. Okay, and wind system. If anyone is having idea the operating zone of the wind, because for very high speed we cannot operate it, so we have to limit the speed. So in that case we have to go for a pitch controller mode where we are limiting the power to the rating of the that is the generator power rating. Okay.
Pitch angle automatically set.
Automatically here we have done the output. We are switching from the MPPT mode to the, because wind speed has power has crossed the limit, so we are changing the pitch angle.
When drives are there, na?
Which one? This is
for
for
pitch
higher
angle
system. I am saying again.
Each controller may have a time constraint.
Yes, time constraint is there, but this is a for a
higher
simulation, higher power rating. In a lab system, I am operating in a normal scenario, but suddenly wind speed is increasing. I am creating that scenario. So it has to switch from MPPT controller to the pitch control mode so that I can restrict the power, limit the power. So how I will treat it? By what you are saying, by increasing the P channel. Okay. So that is, so the mode will change from mode 1 to mode 2. Again, what is this off MPPT mode? When means power is within the limit, but excess the battery cannot regulate the bus voltage. Means battery is either overcharged or discharged. So I have to disconnect the battery. So in that case, who will control the bus voltage? Not possible. So there will be large fluctuation in the bus voltage because only one source is there. Okay. So in that case, I will switch from 1 to 3, which will regulate the bus voltage. Now it is not operating in MPPT mode. It will, this bus converter or boost converter, whatever we are choosing, that will operate in a closed loop condition, so that it will regulate the bus voltage. So that one, what we have seen, and this is the same VDC controller which already I have explained. And this is the corresponding what I told. In the flow diagram it is explained. Mode 1 when the SOC is within the limit. But already I told, if mode 1 operation when the battery is in a safe operating zone, means the SOC of the battery is within 50 to 90%. Then depending on, first we will check whether wind power is there or not. If yes, so but it is less than, if PW, first we have started calculation after that, whether it is less than rated or not. Okay. If it is less than, rather than the rated, then obviously we are going for a switch control. If it is less than that, then it will check the SOC. SOC is within the normal limit. Yes. Okay. Wind power is not there. Yes. Then only battery is there. Battery only mode. Okay. Only battery will supply the load. There is no wind. Okay. Similar thing we can think of with a solar system. Okay. So considering these cases, you have battery charging, discharging mode and MPPT under the SOC. That is the normal scenario. And when SOC is not, means either it is above 90% or below 50%, and that SOC lower limit also you can set it to 30-40. We have also worked with that, depending on what you are setting. Okay, your lower limit of this. So based on that, again, this VDC, this I will explain with the results so that it will be more clear to you. This off MPPT, that means your renewable energy system, that converter will operate in the closed loop mode. That bidirectional converter will disconnect.